without messing that Elasticsearch security have been automatically configured. This is a password for Elastic user. So there's a password. It is automatically generated for you for the Elastic user. And there is some CS certificate. And look at this one. Configure the Kibana to use this cluster, right? So that's what it is. So keep in mind, this is what you're going to, copy that into Kibana's console, which we are going to come back to that in a second, okay? So this is something which is going to be output onto your console when the Elasticsearch is run for the first time. That's not the case. So that's not your Elasticsearch is running, but anybody who is trying to talk to Elasticsearch will have to go through this process, in the sense like they had to go through now using the Elasticsearch, Elastic username. They had to input. Before that, they also had to use the enrollment by sending the token as well, right? So what happens is that you get a link like this. So it says actually holding up setup until pre-boot stage is completed. What it means is that your security is not yet configured. So it's just halts there to say, this particular one is the code. Can you go and click on this one? That is what you do is the copy or click on this one, and it'll take you to a screen where it'll show you like this. It says, can you paste the enrollment token from the terminal? Remember I shown you the enrollment token? That's this one. This is a copy of the following enrollment token. So from this EY to this J9, this is your enrollment token. So go to copy that enrollment token from your Elasticsearch console into here, and you click on the configure top Elastic. You are good to go, right? That is now. Once you are good to go, what I mean to say is that you still have to remember or copy the Elastic username and Elastic password. Again, you have to go back. Sorry, I'm not sharing my screen YBM. Actually, I'm using the slides at the moment. I'm using the slides. So on the configuration, once you go to your Kibana, all you're going to do is that use your Elastic user and password. For example, if I go back to my this one, if you see the second line here, it says the password for Elastic user is so and so. So use the Elastic and use the password, and you can log into Elasticsearch. Okay, or Kibana rather. Again, unsecure way, I already told you how to do that one, so we don't need to worry about at this point of time whatever it is, right? Perfect. that ends the configuration and installation of the Elasticsearch. I do have to just give you a very, very brief introduction about where exactly the Elasticsearch changes its codes, in the sense like is Elasticsearch or is any of the modern search engines, I mean, they've been there only for last 10, 20 years, right? Before that, we used to use something called database power searches, and how relevant they are, how we managed to move away from using the database as a search engine the search engine as a search engine, and into a newer bird or newer engines like Elasticsearch, which gives you much more sophisticated way of searching the data, as well as analyzing the data, as well as running the machine learning algorithms on the data as well, mostly in real time, right? So something which is an awesome feat. When we come back, I am going to give you a little bit more information about this is a running application, running search engine on my Mac Mini, right? So that is a single node. That is a node. Fortunately, what happens is that you don't need to do anything at all, but that forms a cluster. So cluster is a farm of machines, a farm of nodes, which are nothing but running Elasticsearch engines, right? So when you have, let me, excuse me. Let me go to this guy. Okay, let me clear this up. Very, very first time when you do that one, that's your first Elasticsearch, right? So that's your node one, right? It's a node basically, right? Ultimately, this is running on your own single PC or on your own machine, perfectly fine. Now, if you want to run the same thing or another node, you can certainly run the second node on your machine as well. If you want to use the same binary, you may have to split the paths of data and paths of log, but that's not what we're going to discuss here. But you can certainly run the second node as well as the node. It depends on how memory hungry or how much your application or your PC can taken, right? So let's say I have run 3 applications. So in this case instance, all I'm doing is that I simply go to, for example, in this, I created a 2-node cluster here, for example. So this is a very, very primitive way of doing the job. Let me show you what I did. I have a node 1, node 2, and node 3 here. Oh, sorry, node 1 and node 2. I did not create the node 3, but you get the point anyway. So if I go to node 1, right, I have again the libraries here. So the binaries are already here, right? So all I have is just separate node information, sorry, separate binaries for node 1 and separate information for node 2, right? So if I go to configuration of Elasticsearch, the only thing I changed was basically, remember Elasticsearch, I want to change this to VI so that I don't need to go to CI. If I go to my configuration of the Elasticsearch for the node 1, right? Node 1, look at this, what I did. I made changes to the cluster name, so that means I'm specifically giving a cluster name now. I also changed the name to say this is my node 1 instead of just letting the any name what application server wants, right? And I did not change any of these two, right? But if you want to use the single binary, in this case I have 2 binaries, right? Node 1 has got their binary and node 2 also has got its own binary. Both binaries are picking up the configuration from the same from their own respective locations. But if that is not the case, if you want to use a single binary, let's say you have a binary on 2 node on a high level, and then you want to just set the use the same binary to create a farm of 10 nodes, right? In that case, you may have to override this path route data and path route logs to wherever you want that particular node to output the data. I mean, we are not going to discuss that, but just keep that in mind. Nothing else other than that one. I didn't make any changes. You can simply use it. You can simply use the 9200 as well. If you want to change it, you can change it to whatever the port. But I left it like that, actually, right? So same things. I have done it on the other one as well, on the second node 2 as well. I left the cluster name exactly like that. Instead of node 1, I managed to make it as node 2, right? Once you're there, all you're going to do is that you're going to start the node 1 and start node 2. Nothing fancy there, nothing sophisticated there. It's a very, very crude way of starting up 2 nodes on the server, right? So once you can always create another one as well if you want, node 3 as well. Ultimately, what happens is that you have created a node 1, you have created a node 2 on the same VM, same machine. Remember, my machine is, let's say, Mac Mini. On that machine, I created node 1 and node 2, right? I mean, obviously, this is running, this is using file system someplace, and this using file system someplace, right? So it's writing the data to a particular folder, it's writing a data to another folder. Both of them, right, are now forming a cluster, right? Both of them are actually in a cluster. And that cluster is called, in this case, OLT bootcamp cluster, right? But ultimately, that is a cluster. It's a multi-node cluster. It's called this is because you have 2 nodes, then that forms a cluster. You don't need to do much about it. Fortunately, Elasticsearch, when it is started up, Elasticsearch first picks up 9200 as a port server. When you do the second one with the same cluster name, it's going to say 9201. Right? And if you have third one, for example, the same machine or same network, it is going to use 9202 and so on and so forth. It's going to update the port number as well. You don't need to do anything at all. You simply change it, right? I mean, that's one of the crudest way to start your multi-node applications or multi-node server, which forms a cluster. But the main point I wanted to come back to that is, why would you want to do that? Right? What is the reason why you want to do that? Or actually, why would you want to create a cluster? Right? So that is the infra side of things, which we will cover. Actually, let me cover this now, and then we'll jump onto relevancy, because I really want to go to relevancy quickly. So let's say I have a farm of computers. So this is my VM1, and I also have VM2 here. Okay. Now, Ideally, by the way, this is a very frowned upon way of setting up your Elasticsearch. You should never set up the nodes more than one on a machine. So you should always have one node on one machine. You should never have more than one. But of course, it's up to you. But ultimately it's up to you. Ideally, that's an anti-pattern, which I think I shouldn't be encouraging you to do at all. So in this case, I have two virtual machines or two machines where I have created N1 and N2, and because they are in the same network, they form a cluster. So basically, this is now a cluster of X number of machines, right? So let's say this is a cluster called C1, right? So these are happy days. Now you started pumping in data. Let's say you got the Twitter data from Twitter database, and fortunately, today's data was only 1 gigabytes of data or 10 bytes, and then it's able to take it. That's perfectly fine. It replicated from here to here, there to there, doesn't matter, everything. We're going to talk about that towards the probably next class as well. Ultimately, what you have here is a mechanism of storing the 10 gigabytes of indexing data, and at the same time, you also have a mechanism of searching the data as well, okay? Now, the problem comes in here. Let's suppose the next day when you're running it, actually, that 10 gigabytes of data, what you expected, that may have exponentially grown to, let's say, 200 gigabytes of data, okay? So that means this is what you're expecting now to be held up in your virtual machine. In that case, this is the beauty of it, actually. Just only hear me out, okay? This is the beauty of Elasticsearch. What I can do is that I don't need to bring them down. I need to add some extra memory, etc., etc., etc. Don't do anything of that sort. Instead, I just simply provision a new VM, VM3, and just like a node 2, node 1, node 3, it's a machine, right? Remember, with the same cluster name should be, of course, the same, and the same network, you boot it up, right? That's it. Now, if you boot it up, now this also becomes part of the cluster. So that means you got 3 clusters now. Earlier, let's say this is 50 gig of memory, and this is 50 gig of memory. Now you got another 50 of it. So that means 150 is your automatically spread out, right? Remember, you did not do anything at all. You don't need to bring any of the servers down, nothing from your side. Automatically manages. The Elasticsearch is going to do all the things behind the scenes to say, aha, I got a new node, so I'm now going to use that space as well. So in this case, because we have 200 gigs of data, this is not going to be sufficient, right? So we may want to bring 3 more, let's say 3 or 4 more or whatever it is, right? And that's it. Now your cluster has been scaled horizontally, right? Rather than vertically scaling up your machines, you're scaling up your clusters horizontally, and that too by not bringing down any of the servers or not tweaking the memory on each and every server. Instead, you start adding your nodes, and this adding of your nodes in that particular farm, there's no stoppage. You can have 5 nodes, you can have 10 nodes, you can have 100 nodes, 1,000 nodes. Your own choice, of course. How you want to manage it is all up to you, right? So if you write a simple automation script, that should be able to go and do the job of creating this 100 nodes for you, do the farm of all your 100 nodes, and once the cluster is formed with those 100 nodes, then it's the headache of the Elasticsearch engine to distribute the data from the first 2 nodes onto the rest of 98 nodes. Right? So that is the cluster side of things. So I wanted to just finish that conversation around 2 node. So we got 2 nodes cluster here. If you want to run 2 nodes on your machine, simply, rudely or very, very crudely, not really, crudely, you can simply copy the binaries into 2 nodes and then run up. That should be fine. Or you can have the same node, the same binary, but change the configuration file for both of them because they cannot point to the same logs and the data path. Okay, so with that, let's jump on to the slides for 2 seconds. By the way, I may trying to focus on at the moment to see how we can go for Elasticsearch. I want to do background to be done first, and then we come back to Elasticsearch installation. Okay, see, that's what it is, Elasticsearch. CW, I hope I answered your question. Elasticsearch is a search engine, an analytics engine, and also kind of a data store, although I don't use a data store as the primary truth store. You can create that as probably a little bit as a secondary store, I would say. Yeah, keep that in mind. So far, we have done the part of installation. Now we're going to take a different turn. We're going to go a little bit of theories. If you're bored with theory, Unfortunately, it's not going to be, I would say probably stay around, because most of the things are actually, I'm going to go through with the diagram, so you'll understand very, very, very easily. Okay. So let me quickly go through the bits and pieces what I want to explain to you about the Elasticsearch, right? So it's an engine it's an open source search and analytics engine. That's period, nothing more than that. Okay. What you have to consider this as a modern search engine. Okay, that is the difference between the search and the modern search and the older search, right? So there is a concept of relevancy comes into picture. So just imagine when you go to Google. This is a very simplistic example I'm trying to give you, but just go to Google. You search something on Google, right? When was the last time you went to second page? Never. Probably not, right? When I say second page, means second page of results, right? Normally, you don't go to second page or third page of Google, and in fact, actually, you don't even go to the bottom list of the results anywhere. The top 5 are the 90% of the times they will be satisfying your criteria, the top 5 of the list, right? What Google is going to give it to you, right? The reason is that the Google engine is now trying to do something called relevancy trying to bring something called relevancy into picture. What it means is that what you're searching and what it has is going to compare to each other, and it says, okay, this particular document or this particular data seems to be very, very close to what user is searching, right? So I'm just going to send that data, and that is a closeness that is called relevancy, right? So you don't want to, if I'm searching for Elasticsearch on internet, I shouldn't be getting data about maybe some other search engine, or maybe the search, what do you call elastic bands, right? That rubber bands, whatever you call. That's completely irrelevant. I don't need them. Now, there is a lot more scope that you should understand about the relevancy, but for the time being, just relevancy is all about how close the documents, that the search results are to the user's criteria. How close are they, right? Now, just take a step back, understand the same concept from a database side. Okay. When you make a call to a database, and when let's say you jumped onto a database and you say queried for flights that were cancelled in the last day or two, right? Or trains which were running late, or maybe what are the sales figure forecast or the sales figure for the next quarter, whatever it is, But remember, that is more of a binary search. What I mean to say is that if there are no cancelled flights, you won't get the data, right? If there are no sales forecast created by your sales manager or sales analyst, there won't be data coming to you, right? And also, if this is all about yes or no answer, so you ask something to the Elasticsearch, to the database, and it's actually going to give you data back, yes or no. That's pretty straightforward, nothing more, nothing less, right? It doesn't use the intelligence of searching through its database to say, okay, user is searching for cancelled flights. So can I go, there is a flight which seems to be deferred, or which seems to have been called undeterministic. I'm just making up the word here, but some other type of cancellations, they might have been there, right? But it's not going to use any of that intelligence. It just simply says, in a table, do I have cancelled against a flight called cancel status, yes or no, right? If it is a yes, okay, I'm going to send that in part of my list. If it's a no, doesn't matter. On top of it, whatever the results you're actually going to get it from the database, they're not ordered based on your search criteria, based on your relevancy, right? So what I mean to say is that if you jump back again onto the Elasticsearch, onto Google, right? If you go to, for example, if you go onto Google, when you do a search, all the results, what you're actually going to get it, they are all from the perspective of, let me show you, they're all been given to you as a, how shall I put it, so think of this as, so the data what you're getting from the Google search, if you see, it tells you how many results it's got it, as well as it tells you, it will order those results in the format that you feel that the top one is the most relevant, the lower one is the less relevant. As the relevancy goes down, or as you go down through the list, the relevancy of the document for your search criteria becomes much more irrelevant, right? Keep that in mind. Now, let me show you an example of what I mean. So let's say I go to Amazon, okay? So you want to search for router. Now, obviously, can you see that when I'm searching, I can see that all the search is already giving you that search. So that is the modern search engine's capability. That is actually going to, excuse me, is actually going to trying to say, these are the suggestions I can give you. Are you searching for Wi-Fi router? Are you searching for extenders? Are you, whatever, those kind of suggestions is trying to give it to you, because it knows that these are all the things that are available in its own stash. It's actually giving it to you. So this is one of the criteria of a search engine, right? When I do a search, I get quite a lot of things here. Okay, let me do. So there are a few things here. I mean, there's some search results here. There are some tweaks, the filters that I could use it, and so on and so forth. And each of the search filter has got some data. The result has got so and so, right? And you also have some the things on the what do you call sponsored, some of the sponsored stuff as well. If you can see, there is a sponsored here. Some of them are sponsored as well, right? Now, if you look at it, right, these are all something called, these are all given to you, something used by something called a relevancy, right? It thinks that, it means like Amazon search engine thinks that when you search for Wi-Fi router, this is the router you are looking for. This is the router. These are the routers. But as you go down the list, probably those relevancy might be not that great. The relevancy might have kind of a, not, I wouldn't say not bad, but I say probably you don't really, for example, you can say this is nothing to do with the relevance. In fact, it's something called a sponsored link, right? There's nothing to do with the Wi-Fi routers at all, right? So why would you want to have it? That's a different discussion. I mean, we don't need to, but it's one of the ways promoting that, right? There is a Wi-Fi mesh. Probably I'm not asking for a mesh, but I got it a mesh system here, right? Although it's a router, but it's not necessarily I'm looking for. So as you go down the list, those relevancy is actually going to be dropped, or the effect of relevance is going to go away. The top one are the most relevant ones. That's what determined by your Elasticsearch or by your engine. Amazon given by a very, very beautifully written and architected APIs. I mean, you will see the RESTful APIs, how they are used, how exactly you can mend them to get the data for you. You can create advanced queries. You can go to any length, whatever you want, right? So there's a really, really awesomely prepared APIs, I would say. Now, in addition to just using the Kibana, if you are working on a search service built in C# or built in Java or built in Ruby or Python, you don't need to worry at all. You don't need to come to Elasticsearch and onto Kibana and start querying and then going back to your application and doing something there. No, there is a library for each and every one of these. Actually, if you're looking for a Node.js server integrated with Elasticsearch, there is already a library. All you have to just package Elasticsearch npm module into your Node.js server and simply use the HTTP client to invoke the clients. I mean, create a client request, use the HTTP client, invoke it. That's it. Everything is over HTTP. RESTful interfaces are exposed over HTTP. So it's really awesomely designed from that perspective. So native clients, you don't need to worry at all. As I said to you, most of the programming languages nowadays, they support RESTful interfaces support anyway, right? You can talk to HTTP over REST over HTTP. So simply use get, put methods, all these things with your invocation of your URL. You are good to go. You don't need to worry at all. The last bit I wanted to really touch base is the modular architecture. You have, I think I got a slide in about 2 slides from now. I'm just going to show you the stack of product, the suite of products what Elastic has, which I'm going to come back to the other point that I'm going to discuss is modular architecture, what it's all about. But ultimately, you can mix and match the bits and pieces what you want in that architecture. You can use Logstash, you can use Elastic Beats, or you can use the Kibana, or you can use your own way of constructing all these things, or you can throw away one of them and then use the rest of them as well. It's up to you how you want it. Okay. Again, these are the features from the top, very, very high level. I think we may have done a little bit of touching of these things a little bit here and there, but predominantly every time I talk about it, I talk about something called full text. Okay, so in the lingo of in the world of Elasticsearch or modern search engines, full text is the kind of a human readable text. Like, for example, if you look at a research paper, that is a full text. If you look at a blog post, that is a full text. If you look at a description of an item, it's a full text, right? The problem with the full text is that you and me can understand the full text very, very easily, but the machines, they don't understand, right? So let's suppose I have written a movie review about X and Y and Z and posted it, right? And that movie review is, let's say, 3 paragraphs, okay? That's the free text, that's full text. It's just kind of a text, right? Now, when I'm searching something in that text, if it's a database, it'll just only match 1 or 2 words, and it says like, or so and so. It just kind of says, no, I don't bother. I can't find it. Whereas if it's a modern search engine like Elasticsearch, if you're searching for some sort of a synonym, some sort of a including grammatically incorrect mistakes as well, it kind of manages that search for you. He kind of says, okay, maybe this is what he's trying to search, so he's going to give you back the details to you. That is the full text search, right? It gives you suggestions, as we already seen on the Amazon site. It gives you the search suggestions. It gives you the auto completions. And fuzzy search. Fuzzy search is all about correcting your mistakes. Most of the times when you go onto Elasticsearch, Google, for example, when you start searching for nearest wife, you'll say, do you mean Wi-Fi? Because you don't want to search your nearest wife, you want to search your nearest Wi-Fi, right? So it may say, is that what you mean, right? That's something which kind of automatically suggests you, right? And if there are any spelling mistakes in your search input, it kind of tells you, or it kind of goes and gets you the data for the corrected part as well. You don't need to worry at all. Geo queries are really, really advanced queries, really very important queries nowadays. Deliveroo. If you go into Deliveroo, where are my local restaurants, or if you go into maps and find out where you are roaming around and what are the restaurants or cafes around you for 200 kilometers, maybe 2 kilometers, around 200 kilometers, 2 kilometers, and then get those things. I mean, that's all works. The search is always working because of the modern search engines like Elasticsearch, right? And I don't need to go about the analytics and the machine learning, but they are always straight away available. On the right-hand side, you see the technical features or technical capabilities. Again, I'm not going to drum up all those things again and again, but it's a distributed, highly available architecture, right? So you can add nodes as you wish. You can add, if you think that there's a Black Friday sale coming up or Cyber Monday coming up, and if you think that you need to have to support machine, support the search from instead of 100,000, maybe 1 million, 1 billion users, be my guest, just all you have to just throughout the night start setting up your farm. Just add more nodes to the farm. And nowadays, building VMs is pretty straightforward anyway, right? It's not a big thing. So you start dumping an image onto those nodes, and then you're good to go. You don't need to worry at all. Or you can go into a cloud hosted service like Azure or AWS or Elastic itself. You can do whatever the way you want that way. Right. So again, one of the important things is that when it comes to Kibana, you got plenty of visualizations. Really, really awesomely created visualization. You can share this dashboards to your manager, to your business analyst, or your groups, etc. It's quite it's quite easy for you actually. That's not a big thing for you to worry about at all. Now, fault tolerance, I already spoke to you. I don't need to worry at all. Okay. I'll take a breather there because I need to ask some questions.